As I've mentioned before, preparing data is often the bulk of the work when you want to do data analysis, especially in large projects. We're going to begin to talk about relational data. You often can have data in multiple tables that you need to draw from both tables in order to analyze the data. That is, data in multiple tables can be related to one another. The relationship links a pair of tables. And it's possible that multiple tables can be related through multiple pair links. Relational data are most common in relational database management systems, or RDBMS for short. But research projects, especially large ones, often include an informal version of an RDBMS. Anytime we have data in multiple tables that correspond to the same project, such as, for instance, if we have individuals who we have data from in one table, but then we have a different set of data for those same individuals in another table, then we have relational data. Here's an example using the New York City flights data. So the data set that we've been working with, the primary data set here, are the flights data. And those flights data contains years, months, days, hours, flights, what airport it started from, where its destination was, the tail number of the plane, what carrier it was, and so forth. We have 4 additional data sets that are related to the flights data set, and I've given you all of them. One of them, for example, is the airports data set. This is going to give you information about various airports. How is this related to flights? Well, the origin in flights refers to an airport. The destination in flights refers to an airport. So the airport's data can be related to the flights data through the origin and destination. And similarly for the other 3 data sets you see here, planes, airlines, and weather, I've shown you the links that connects each of those data sets to the flights data. You may maintain a database of planes that includes their tail number. Well, that tail number then links the planes data set to the flights data set. These links are called relational keys. Keys are the variables used to connect a pair of tables. A key uniquely identifies an observation. A single variable may uniquely identify an observation. That's the easiest case. But in some cases, we actually have to combine multiple variables to uniquely identify an observation. The key word here is unique. In order to be able to work with relational data, we have to uniquely identify an observation in our data set. So if we can do that with one variable, great. But if not, if it takes multiple variables, we just need to know what those variables are. There are different types of keys, 3 types. A primary key uniquely identifies an observation within the table where it is located. A foreign key identifies that observation in another table. Sometimes you have to have surrogate keys added to a table in order to uniquely identify an observation. This most commonly occurs if we have multiple variables needed to uniquely identify an observation so that we figure out a way to combine them to create a surrogate key. A primary key and the corresponding foreign key form a relation among tables. So let me go back to this picture here. So let's look at flights. So if we have, for a particular flight, a tail number, that can become a primary key within the flight's data, and the foreign key would be the tail number in the plane's data, or vice versa. The tail number would be the primary key for the plane's data and a foreign key for the flight's data. Now, also notice that in the plane's data, the tail number is probably unique. It should be unique. Whereas if we look at the flight's data, there are probably multiple values of the same tail number, that is, multiple rows that contain the same tail number in the flight's data. So if we link up the plane's data to the flight's data, we're going to be linking up multiple values of the same tail number into the flights because that plane is used multiple times in the flight's data. So since a key has to uniquely identify a row of data, tail number is really a primary key only in the plane's data. Nonetheless, because we have a foreign relationship in the flight's data, we can link up the plane's data to the flight's data. So let's look at examples of this. So in the plane's data, a primary key is the tail number. So I'm going to read in the plane's data. Notice that it has tail number, year of the plane, type, who manufactured it, the model, the engine, the seats, what speed it goes. Engines probably is number of engines, and then the type of engine is called engine. It's always a good idea to make sure that we have a clean primary key. That is, it uniquely represents a plane in the data set. We don't want to have multiple occurrences of this. So let's do that by counting. So I'm going to create this object I'm calling check tail number, and then I count it and put that in check tail number. Let's see how many tail numbers appear more than once. The answer is 0. Perfect. That means that every tail number appears once and only once in the plane's data. And so we can consider that a nice clean primary key for the plane's data. In the next video, we'll look at when we have to use multiple variables in order to create a primary key.